Thank you all. So today we are going to see a little different topic, which is still in the early stages. It's not yet ready for prime days, but as a we are working in a technical environment, it is always to pleasant experience to know new things, right? So that is the reason I wanted to have a glance at what is quantum computing. And as a .NET developers, most of us are. And as a developer, what we can do now to develop quantum computing using a new language from Microsoft called Q Sharp and new development kit called QDK, Quantum Development Kit. So before getting into that, what is Q Sharp and what is QDK, we will try to understand what is the difference between computing and quantum computing. Okay, uh, or classical computing versus quantum computing. The main difference is the classical computing that we are using our laptop or our desktop or mobile. Everything is a classical computing peripherals, which are all using a silicon based chips, right? We have processor, we have RAM, everything is silicon based, which will have a transistors, right? Which can hold either it can have a binary value 0 or 1. Based on that, it will do the computing. Whereas the quantum computing, uh, you know operated based on quantum physics is a or quantum mechanics, is a branch of physics or quantum physics principles, which will be using atoms, ions, photons, and electrons to do the computing. So uh, the the normal principle, like theory of relativity, if you take law of mechanics, right, laws of movement, law of gravitation, nothing will work in that environment because it's a atomic and subatomic level computing. So you cannot expect, you know, at this level that will be this state, this level that will be that state. You cannot predict that. So you need a special environment to run quantum computers. So you will need a sub-zero level temperature to run quantum computers. So you will need hydrogen cooling. You need so much power. There it is still placed in universities and the research labs, not yet available for public. But the quantum computing has a potential of solving several problems like you know uh, climate change and traveling to Mars, cracking your encryption, guessing, brute forcing your password. There are several potential applications will be possible using quantum computing. So so one of the first there are several keywords or several base concepts or key concepts we should understand in quantum computing. One of it is superposition. You may get a feeling that all this terminology I'm going to use here henceforth will be like watching a science fiction movie, because okay, in binary computer, as I said, the binary computer is what we are currently using, right? Previously we used vacuum tubes in early 1900s and moved to transistors, which we are currently using. There is a debate between 10 nanometer and 7 nanometer and 5 nanometer. There is a uh, competition between the Intel and the AMD, and then there is a you know uh, you know ARM processor. These are all dealing with binary computers, which can only work on zeros and one. Okay, each unit of binary computers can hold either 0 or 1. Okay, that is whether it will be true or false, whether it will be on or off, something like that. Whereas in quantum computing, each unit of quantum computing can hold either 0, either 1, or both. That is known as superposition. So just imagine the possibility of that, right? Each unit of quantum computing can be 0 or can be 1 or can be both. Then the possibility of information can be processed or stored is exponentially exponential possibilities or probabilities. So that is the the superposition. Uh, in a real world example, you are exercising and somebody, if you are exercising, either you will be turning towards right or turning towards left. You cannot change, you cannot, turn towards both sides unless until somebody cut you in half, and then, in like a horror movie, somebody cut you in half and then, turn into both direction. That is not possible. But whereas in the quantum computing, you can be both in left and right, and also in both direction. That is the possibility of, and that concept is known as superposition. Okay. Okay. Then there is a concept called quantum measurement. What is quantum measurement? Is, okay, when you uh, look at that unit which is in the superposition state, either it is not 0 or 1, maybe both. When you look at that, okay, that will become either of that state. Okay, it will become 0 or 1. That is known as quantum measurement, or it is collapsible state. That's what they're calling in quantum computing. Little buzzwords, and also known as decoherence. These are all, derived from physics. It's not at all computing related thing, but computing is one of the derivative of quantum physics. Okay, and so it can be 1 and 0, but when you try to look at that or observing that unit, it will be collapse, and then result of that collapse or decoherence, that unit will become state of 0 or 1 based on some algorithm or logic, something that is known as quantum measurement. So we have superposition, which is saying that it can be either 0 or 1 or both. Then we have quantum measurement, which is a result of collapses happening on that unit. Then there is a entanglement. Entanglement is a more like a science fiction. Okay, this is more like a telepathy kind of thing. Okay, when two quantum particles, okay, either it is an atom or electron or proton, ions, whatever it is, they had, they had an ability or chances to have a communication or entanglement with each other. Then means, if you put one of that particle, if you take one pair of quantum particle, and then somewhere in that process, both particle entangled or touched something, right? Then if you put one particle away from one particle, it can be a 1 kilometer distance, or it can be a light year distance. But these two particles can be communicated without any medium. Just imagine. This is like more like a time traveling, pakka science fiction kind of concept. So there is a particle A and then particle B, okay, and then they entangled, and then you are putting this particle B somewhere in the Mars, okay, but there is no connected medium here. But if you do something on the particle A, that will be immediately reflected on particle B without any medium. So there is no latency, there is no communication device needed. Nothing is needed. That will replicate what is happening on the particle A. Thus also, if you do some optation on particle B, that will be reflected on particle A. For example, Tesla is or SpaceX is promising journey to Mars in another 5 years, right? If there is a possibility of communicating to Mars, station without any satellite or any medium, the how that will be. Okay. Okay, that is entanglement. So we talked about superposition, and then measurement, and then entanglement. Next one is qubits. Qubits are uh, you know is a it's more like a bits in binary computing, but it is a quantum bits. Quantum bits is a storage, or it's a measuring unit in quantum computing, where it can be, yeah, it can be superposition, foldable unit. So it can be one or zero, or based on it quantum measurement, it can be a finite value, either zero or one. So and also you can apply filters on the qubits, where if it's a group of qubits, where it can be 70% of that qubit is zero, and then remaining is one, or vice versa. So it's a more like a qubit. It's not only holding the data, and also applying a law of probability, because this is you know uh, the computing environment itself. It's not finite environment. It is more like a unimaginable atomic and subatomic level computing. So it allows some certain of probability to be applied, so that you can have outcome in a desired manner. So it is more like a mixture of probability, machine learning, and everything is built into that system at the concept level, not only the application level. The basic level itself, it will have. So, for example, in if you take each bit can store one or zero, right? Together, it can store four possible cells: zero, zero, one, or 1011, something like that, right? Only four possible values in 2 bits, right? Whereas in qubits, it can be uh, I think 8 possibilities. I think 8 possibilities. Yeah, 2 power 3. Uh, Correct. 2 power 3. It is eight possibilities. So 8 power 2. It is, yeah, 8 possibilities are there. So the storage or computational units and everything is scaled, in multifolds, right? That is the tremendous possibilities are there. So I'm going to share my screen. Okay. Uh, okay. You're all seeing my Visual Studio, right? Okay. So you can run quantum computing programs locally using simulation. It will have some error, at some level, but the beauty of it is, and in your Hello World, if you learn a new language, it will be always a hello world, right? That's what we will be doing. We will write console.train hello world, or console.log hello world. That's how we will start learning programming. So in Microsoft, they have released a language called Q Sharp. This is more look like C Sharp, and any other object oriented language, but it is a quantum programming language. But here the hello world is a teleportation, or teleportation is sending something or someone from one place to another place without any physical medium. Okay. For example, if you are sending someone from here, from Chennai to US without any flight or any travel medium, you will that something or person or animal, whatever it is, or information, anything requires a medium to travel, right? If you are if I'm making a call, that is communicating through all of the communication backbone, everything is there. But if you are able to do that using the entanglement, superposition, that will be the hello world program in the Q sharp. So this is a typical language feature. Just I want to uh, running. This is just a thing. So we tried the this is the output. You're all seeing.
Yes, Aslam, we are seeing.
Uh,
But we cannot see the output, Aslam.
Yeah.
okay, yeah. Let me share my. Now, okay,
Yes.
okay. So we tried teleportation in simulated environment several times. We're getting true several, false several times, right? The true, how many times you got a true, that is a non-errored execution, whereas you got false, it is a errored. They are simulating the quantum environment. Just imagine how it will behave, in a temperature spike. If you are dealing with atomic level, that requires a stable environment, right? You need to maintain the temperature. That's what they're stimulating. So this is the new language. I don't have any much idea about it. Uh, there are some syntax available. QNAP, the measurement or computing unit in the Q sharp. It is a it has a lot of potential. You can crack your password or encryption algorithm in a matter of second if it does, come into public availability. It is, um, you know, maybe this everybody talking about bitcoins or cryptocurrencies, right? That will become cheaper, maybe, because nowadays to 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 mine a Bitcoin or any cryptocurrency, you need a lot of computational power. I think in global consumption, the cryptocurrency miners are consuming more power than the any other industry now. So that will become cheaper with this quantum computing advancement. Also, this is a niche, it's a new subject, you know, but it will be an interesting subject for somebody who work to in a side project or as a learning project. That will be a good thing to learn. This is a lot of potential, a lot of unknowns, but just I want to give uh, give some introduction to that. With that, I conclude this session. Thank you. Over to you, Julie.